So the diagram shows three resistors in the parallel. What's the effective resistance? No, do you remember the formulas for parallel? Can you tell me what are the formulas for parallel? Parallel arrangement. Well, okay, I'll give you a clue. 1 over RT equals what? Yep. So it's 1 over 4 plus 1 over 2 plus 1 over 1. Now if you do this, you get 7 over 4 using your calculator. But remember this is 1 over RT. Then you gotta flip this. So RT equals to 4 over 7. Hence the answer is A. Okay, next. So first we must connect the two. Now because this is two series in a parallel, you take 1 plus 2 equals to 3. 3 ohm. These two series you add them like that. Then 3 plus 3 is 6 ohm. Right. Then we use the 1 over RT again. 1 over RT equals to, now because the top is now 3, so it's 1 over 3. And the bottom is now 6 plus 1 over 6. And this will be equal to 1 over 2. Okay, why is it 1 over 2? Because it's 2 out of 6 plus 1 out of 6. So it's 3 out of 6, which is half. This is half. Then, same thing, you need to flip. RT, you just flip this, so it's 2. Hence, the answer is B. Correct. So, how do we get C? Because this is voltage and current, correct? So, you know R equal to V over I. V over I. So, you got to take the voltage divided by the current, which means you draw a triangle. So, 20 divided by 4, so we get 5. So, that is C. Okay. So, why is it D? Okay, so you see a length of wire 0.5 meter, cross section has a resistance of 0.75. Same material, length is 2. So the length increased by 4, factor of 4, right? 0.5 to 2, which means that does the resistance increase or decrease? First of all, when the length increase, resistance will increase. So here 4 times, you take 0.75 times 4 as well, which becomes 3. Then next, cross-sectional area, previously was 1, and then now it became 0.5, which is half. That means smaller. Now remember, cross-sectional area smaller, higher resistance. So since it decreased by a factor of half, the resistance should increase by a factor of 2. It's the inverse. So 3 times 2 equals to 6. So the answer is 6. Okay. So the formula is I equal Q over T. Q over T. The question is how much charge. So they want to find Q. So Q equals to IT. Okay, so I is 3. Now T is not 5. Now use 5. You must convert to seconds. Yeah, D. Okay, so the time, so you must take 5 times 60 times 60. Next one. So a wire of length 2 meter, cross-sectional area 0.5, resistance 1.2. So this is the reference. I know that if it's 2 meter and this is 1.2. Now another wire, same length, same material, length is now 0.5. So from long becomes short. So when it goes from long to short, does the resistance go up or go down? That's the first question. Yes, Charlotte, go down. Why? Less friction. Okay, so resistance go down by how much? Can you see from 2 to 0.5 is factor of 4 times, right? So this one divide by 4, so become 0.3 ohm. Now next, cross-sectional area, at first is 0.5, now it becomes 1. So cross-sectional area increase. So does resistance go up or down? Right? Become bigger.
Down.
Yeah, that means the resistance go down. Okay. Now the factor here is twice. Okay, so this one will divide by 2. So instead of multiply by 2, because it goes down, this one divide by 2. Hence the answer is A. Okay, so the circuit shows a battery, 3 resistors, 3 ammeters. Which one shows possible readings? Okay, you say B, right? So if here is 6, here 4, here 2. Yeah, B is correct. So let me explain why. Now, if you look at this, we know that A1 is equal to A2 plus A3. That's the first thing. Must be A2 plus A3. Why? Because according to the parallel formula for parallel circuits, I equals to I1 plus I2. So the I equals to I1 plus I2. Okay. Now next, the question then is, why this one 4 and this one 2? Why not 2 and 4? How come we know that the current here must be 4 and then the current here must be 2? Well, it has got to do with the number of resistors. So you see over here, the one at the bottom, right? There are 2 resistors, and then the one at the top only got 1, which means more current will flow through here. Why? Less resistance, what? Less resistance means more current, more resistance means less current. And in fact, it is proportional to the number of resistors. Now, assuming they are all, you see, they say identical resistors. So this is at exactly twice. The resistance here is twice of this, which means there'll be half the amount of current passing through here compared to here. That's it. That's it, B. The same idea, right? Less resistance, more current. See here, there's only 2 ohms, so the current is twice of 4 ohm. Okay, next. Now the circuit connects a 3 ohm resistor, so we know that this guy is 3 ohm. And voltage 2.5. Now this is 2.5 volts here. Oops. Ammeter 500 milliamp. Now 500 milliamp is how many ampere? You want to do conversion, you know? Good, 0.5. Okay. So it's 0.58 because milli is 10 to the power negative 3. So you just divide by 1000, right? We get 0.5, right? So basically what it means is that 0.5 amperes of current flow through here. Now we know that because this part and this part is parallel, correct? The voltage here and here is parallel, which means the voltage across these two is also 2.5 volt. Now I know that 0.5 amp passes through here. Can I find the voltage? Yeah, formula voltage V equals to IR. So I can find the voltage here, which is just 0.5 times 3. So 0.5 times 3 is 1.5. Okay, so voltage here 1.5 volts. And since these two add together should be 2.5, hence here must be 1 volt. Yeah, because they want the potential difference across the length. So here has to be 1. Next.